Okay, we're now going to look at reflection, and this comes in two forms, mainly two forms: reflection in the x-axis or reflection in the y-axis. We'll also go through reflection in the line y equals x, but that is really an extension. Okay, so first of all, reflection in the y-axis. So just having a look at this graph, if you take this line as your original line and this line as the image, okay, if you think about it, the y coordinates of each point on this line has not changed. Okay, the height of each y coordinate is the same. What has changed is the x coordinate. The x coordinate has been flipped around. Okay, so in other words, all positive x coordinates have become negative, all negative coordinates have become positive. So in other words, what you need to do is replace x with minus x. Okay, so for example, if you started with y is equal to f of x, then the image, okay, the reflection, is y is equal to f of minus x. Okay, so if I was looking at this example, if this was the line y is equal to 2x minus 5, then what I do is I replace x with minus x, so I've got two lots of minus x as minus 2x, and I've got that minus 5 on the end. Of course, the minus 5, the intercept, has not changed. It is still this point. It is the gradient that has changed. Okay? And it's become negative. So minus 2x minus 5. Now, when you're reflecting in the x-axis, okay, now, if you have a look at this graph, we've got this curve. Okay, let's say it is x squared plus 5, this curve, and it has been reflected in this line, the x-axis, or the line y equals 0. So the flip has happened here. Okay, so not only has the graph been flipped upside down, okay, it's gone from a happy face to a sad face. Okay, notice how the intercept is changing as well. That will come into it. Now, if you think about it from a general point of view, what has happened is that the x coordinates have stayed exactly where they are. Okay, they have not changed. It is the y coordinates that have changed. Positive y coordinates have become negative y coordinates. So you need to replace y this time with minus y. So if you had y is equal to f of x, okay, y is a function of x, that's what you're given, then the reflection, the image, would be minus y is equal to f of x. So I've replaced y with minus y. So now you can either think of it as dividing or multiplying by minus 1, or switching them around. You could write that as y is equal to minus f of x. So if I'm now looking at this example, the image is minus y is equal to x squared plus 5. Or in other words, y is equal to minus x squared plus 5. So just multiplying out that bracket, you get minus x squared minus 5. So the intercept has changed. It has gone from being 5 on your graph to minus 5. And the happy face of x squared has gone and become minus x squared, which creates that sad face. Okay? So that's how it works with those two types of reflection. Last but not least, we have reflection in the line y equals x. Now, as I said, this is kind of an extension. It is reasonably unlikely to come up on the exam, but it is good for you to know, just in case if it does. So we've got reflection in the line y equals x. Now, the rule in this case is to really swap y and x in the equation. It's a relatively straightforward thing to do. Okay, so for example, if you had y is equal to x squared, then the reflection is x is equal to y squared. So I've just swapped the x's and y's around. So if you can imagine y is equal to x squared, okay, we use it quite a bit, looks something like that. It's a pretty poor version, but there you are. Okay, then the image will look something like this. Okay, so it is a reflection in this diagonal line y is equal to x, and the equation for this one, okay, on the side, is x is equal to y squared.